Hello, welcome back to the channel. In the last couple of videos, we talked about some of the analytics and tools that we offer for higher ed. In this video, I'm going to switch gears, go back to AI, particularly fine-tuning Mistral 7B for a different specialty in this particular case. I have a previous video I talked about fine-tuning Mistral 7B to extract data out of audited financial statements. And this one, I'm going to see if I can make Mistral 7B an expert or even better than it already is at summarizing news articles. So a little bit about the context, the motivation for this project. I'll show you one of the things that we do at Perspective Data Science is create so not only do we analyze data, but we try to get a sense of what's happening in the news space that isn't always showing up in the data. So we have an AI tool that will scrape hundreds of news articles on a university and sort of categorize them in different areas and then summarize all those news articles. So it's Mistral 7B working in the background, doing all these tasks, sorting, summarizing, and then generating this document at the end that summarizes news articles in various topics, including presidential initiatives, changes in leadership, financial health, any controversies on campus in the last few years, research areas that they focus on. So this is one of the reports. And for these reports, I use Mistral 7B Instruct, the fine-tuned Instruct version, to both identify the articles that we would be interested in, and then to summarize those articles and put them into this final document. So one question that I've had is, can I fine-tune Mistral 7B to make it better at summarizing news articles, make it have more accurate and concise news article summaries? And I think I can do it, and I'll show you why I think that's the case. There's some great data on Hugging Face that I want to try to use. I'm not sure actually if Mistral's been fine-tuned on this before or not, but there is a great data set. If I can open it. There we go. There is a great data set on Hugging Face that has summaries of news articles from CNN and the Daily Mail, I believe. And I'll show you what that looks like. And so this is the data set. It's totally free and it's massive. And I'm going to do a project, and I'm going to start you on the beginning of this project right now, where I'm going to fine-tune Mistral on this data set that includes inputs of articles. So you got a news article here in this column, and then it's called highlights column. It's basically the summary of what's important in that article. And you can see it's a really nice, concise summary of an article, and there's different lengths of articles. And again, nice, concise summaries. So it could be a really nice specialized model of Mistral that I can create with fine-tuning that would be better than Mistral out of the box, at least at the specific task of summarizing news articles and having a nice, concise summary at the end. So that's the motivation for this project. See if I can fine-tune Mistral to make it better at summarizing news articles. So the main focus of this video, though, is I'm wondering what approach to use to fine-tune Mistral. I know I want it to go fast, so I want this to be a quick fine-tune. And I've come across some optimizations that I've been wanting to experiment with. Not sure if the facts are straight. I want to do my own testing with a real fine-tuned script that I'm going to use for this project. And I want to know, what's the best approach to fine-tune Mistral for my specific case. So I'm going to be testing a few approaches for you in this video. One is just the standard one GPU using the TRL trainer. I'll walk through that and what does it look like if I just fine-tune this model on one GPU. And using the sort of standard Hugging Face toolkit for that, the trainer called TRL. It's called the Supervised Fine-Tuning Trainer from TRL. Then I want to explore, I found this exciting potential alternative from a company called Unsloth AI. And they claim to have a 1 GPU script similar to the TRL trainer that they claim is 2 times faster. So that would be awesome. All right, that'd be basically the same as running on 2 GPUs, but actually running only on 1. And so I want to test that in this video and see if that's actually true for my particular case. And you can see I have the link here to Unsloth, really cute website, but go down to where they claim, actually I'm not sure if it's here. There it is. Okay, so I'm gonna test this free version from their website, and they claim it's 2 times faster. In fact, they say 2.2 times faster and less memory compared to what, I'm not sure. So that's one of the tests that we're gonna do. So I'm gonna do sort of the standard Hugging Face module fine tune, then compare it to the to the free version of Unsloth, and then compare that to what does it look like if I do this with 2 GPUs. All right, to do 2 GPUs, you use a package from Hugging Face called Accelerate, and so I'll use that. There's different options within running parallel sort of fine tuning. One is the normal distributed data parallel version, which basically just splits the weights across 2 GPUs and then trains in parallel. That is almost 2 times faster, I believe, but we'll double check that with our tests compared to the option 1 running on 1 GPU with a sort of standard trainer. There's another option though, which is called deep speed, which I've never even tested, I've never tried. So I'm gonna try it here with you guys for the first time on this video as well. And with this video, you get a bunch of code for free that I've put on my GitHub repo. It has two files, basically really easy to follow along, and I'll show you how to use that in this video. All right, so let's get started. I'm going to get right into the code run through. And again, you can follow this link to get all of the code that I'm using here. So the first thing, item of business though, is to set this up so that I have my environment set up, that it will run the script, and I have my 2 GPUs set up. So the way I'm gonna run this is I'm gonna run it on 2 A100s, actually 2 A100s that I own. We have 3 A100 GPU servers here, and I'm going to rent 2 of them essentially. I list them and rent them out on Vast AI, and I'll show you what it's like to rent them. A lot of times I rent them myself, even though I own them. I just don't want to pull them down because other projects are running on these servers all the time. So I'll show you how to spin up 2 GPUs on one of my own servers, and we'll do some testing. All right. By the way, if you want to support me, you can support me by actually using my GPU servers. My host ID on Vast is 93835. All right. I have a series of A100 servers on Vast, and it's easy to find. We're the only ones offering A100 PCIe GPUs in Oklahoma. So you can find us pretty easily that way or with this host ID. All right. So let's get started. I'm going to switch over to Vast AI and show you how to spin up this instance. Actually, I already did spin it up, but I'll show you what it's like if you click on this link. You can find one of our servers pretty easily here. You can see this is the console for Vast AI. And what I'm going to show you is just a quick way to find my machine. We have A100 PCIe GPUs, and you can see there's several from Oklahoma. This is one of ours. This is another machine of ours right here. And at the moment, there are no 2X A100s because I already rented the one that was available. I want to make sure that I had it for this video. So what you would typically do, although I've already done it, is just click rent here after setting up your account. Click rent, and then the instance will show up in your instances page, and then you can interact with that machine. So I don't have to show you that part. I already rented the 2X A100s, and that machine is right here. And again, you can see my host ID and all of that. All right, so this is one of my machines, and the way that we're going to connect to it is through SSH. And I'm specifically going to use my PyCharm Professional IDE to connect So first I'm going to set up the environment that you guys need to run all this stuff, and then I'm going to connect to that environment through PyCharm Professional and run you guys through the code. All right, so I think you're going to enjoy this, and I'm definitely going to learn a lot as we go along, because I've been wanting to do these tests, but this is the first time I've done them. All right, so let's hook up to this server and set up our environment. So if you go to, I'm clicking on the code here. If you go to that GitHub repo, there's two files in there. One is the fine-tune.py, that's a Python file that we're going to use to run the fine-tuning tests. And in fact, it's already set up to run the full fine-tune that I want to run, although I need to change some of the parameters like how many epochs and batch sizes and stuff like that. I just set it up to do some quick tests on speed right at the moment. But then there's another script in there. It's just a text file that shows you how to set this up, what kind of packages we need to install. So all of the bash commands for setting up the packages that we'll need for running this script are in here. Setting up the virtual environment in our GPU server are there as well. All right, so let's do it. So the first step here is to connect to this Vast AI server, my own machine, actually running right down the hall. And so we'll connect to it just by opening a terminal, Control-Alt-T, and I've got my terminal opened here, and I need this direct SSH connect. Yeah, you can use actually either of these. I always use this top one. I think it might be faster, but I'm not sure about that. And so we'll connect to that machine just by pasting in this command and saying, yes, we want to connect, and then entering my passphrase for my SSH key, public key, private key combination. All right, so we're in. We've already connected to that machine. One thing I want to do right away is there's this. I don't know. It's fine, probably. I'm just not used to this setup for the terminal, so I like to disable this auto TMUX. So I'll run this command touch no, TMUX, and then I'll reconnect again. Sorry, I'm used to pasting, but it's not working. All right, so you have to run that and then close the terminal and reopen it again. So I'll copy this again and then reconnect. And we should be in with my normal look here. Sorry, it's just an extra step because I like it to look like the normal terminal that I usually am using. All right, so at this point we're into the machine. This is, it should say root. That's the user that your account, the Vast AI account is on the machine. It's basically we're inside of a Docker container inside that machine down the hall. All right, so it's like an isolated instance. It has Python installed, but really nothing else. So we need to install a bunch of packages here. And so I'll go back to the code to show you the packages that we need to install and how I set this up typically. I typically just start by creating a virtual environment called, well, in this case, I'm going to call it test Unsloth versus 2 GPUs. And then I activate that virtual environment and then install all this stuff. All right, so let's run through that. I'll run these codes, or these lines first. So let's spinning up the, and make sure you push enter there. That it doesn't run that last command by automatically. So you can see now that we created a virtual environment, Python 3 environment, and it's now active. All right, now we can go ahead and install all the dependencies that I have listed in this bash setup file. So we're installing, upgrading pip, installing wheel, packaging, TRL, that's the trainer that we're going to use. PEFT, that's the LORA setup. WANDB is just a tracker. We're not even going to actually use that in the setup, but it's a tracker to track your training over steps. And then Unsloth. All right, and we're using a specific version in the install for Unsloth. We're using an Ampere GPU. This is an A100, so that's an Ampere type GPU. So they have different installs for different types of GPUs. If you're using an A100, you'd want to follow this exactly. So if you're going to follow, it'd be nice if you want to redo this code, you can run it on an A100 or run on one of my machines, and everything will work, hopefully. All right, so this is going to take a little bit to install everything. And again, when this is run through, make sure you hit enter again. I think the last install won't happen automatically. So I just paste this in and it started running. But the last one, for whatever reason, doesn't typically install until I push enter. All right, so I'm going to pause the video while this is installing and come back to you when we're ready to go to the next step. Okay, everything's run through. Like I said, the last one doesn't run automatically. So this, if you didn't pay attention here, it wouldn't be installing this last package, the Unsloth package. So make sure that you hit enter here and install that package. And so it's doing that now. And again, I'll pause as this is running. Okay, we're all set. All of the packages were installed. You can double check this, pip list. Just double check all of this stuff is installed. There's a lot of dependencies. We got accelerate. But you can double check that everything, all the main stuff is installed here. By checking, we have TRL, we needed that. We have Unsloth here, and so on. You can double check that all of these major packages were installed. All right, so we're all set. The next step is to connect our IDE. In this case, I'm using PyCharm Professional. Connect our IDE to this, both to the machine and to this virtual environment on the machine that we've already set up called test Unsloth versus 2 GPUs. All right, so how do we do that? All right, I hope you're seeing, yes, you're seeing my script and my PyCharm Professional environment here. The way to set this up, there's probably more than one way to do it, but the way I always do it is to go down here and change the environment. So if you click on whatever environment, by default you won't have anything set up. For some reason I have this set up on a different environment. I'm going to change it. So I'm going to do add new interpreter. And again, I just clicked on this lower right hand corner here, add new interpreter, and we're going to do SSH. So PyCharm Professional allows you to connect to other computers over SSH. So that's what we're doing here. I love PyCharm Professional. I'm not sponsored by them or anything like that. I just use it for all my work, and it saves a lot of time, especially you'll see basically is like working on any computer, even if that computer is halfway across the world. All right, so we're going to set up a new SSH connection, and to do that, I need the information from our connection here. So I need a couple things. I need this host IP address. I need the username, the root, and I also need the port number that we're connecting to. All right, so I need to enter that information to connect. So the host was the IP address. That's my business's IP address. Static, by the way. If you connect to one of my machines, you don't have to worry about the IP address changing, at least as long as my dogs don't eat the internet or something like that, right? Like I have a backup service provider, and if that one kicks in, the IP will change, but it doesn't happen. All right, the port number is 40535 for this particular Docker container running on that machine. And then, as we mentioned, the root is username. So that's it. So enter that information, click next, and then we have to connect by key pair. All right, and so what it wants to know is where is my private key on my system. I may do a different video, but if you've never used SSH, you have to set it up so that you have a key pair and all of that. And all those instructions are on VAST. There's lots of videos about how to setting up SSH on your computer, either Windows, Linux, whatever. But I'll go ahead and point it to my my private key. So my private key, as in most Linux systems, is going to be saved in a folder called .ssh that's kind of hidden, and it's called IDRSA in my particular case. And then the public key is in this file here. All right, so there's the file for my private key, and then I just enter my passphrase. I have a passphrase attached to the public key or to the key pair. You don't have to do that, but I do for additional security. All right, so I entered that there and click next, and we're connected. All right, the next part is to connect to the actual environment that you want. You can create a new environment or connect to an existing environment. And of course, we want to connect to the environment that we just set up. So I'm going to click existing and then find that environment that we just set up. All right, so I know where that environment is. You can go back and look at the bash setup. It's just setting it up on the root directory. And so we go down to root, and we created a folder called virtual environments. So there it is. And then we created an environment within the virtual environment folder called test Unsloth 2 GPUs. So there's our environment. We need to actually grab from the bin folder in there the Python file. All right, so I usually use this Python 3.10. All right, so we need to click on that. And so hopefully you followed all that. You go into the bin folder, highlight Python 3.10 and click OK. And that's going to be our interpreter, Python interpreter. All right, and you can click create. What's going to happen here is there's a sync folder. It's going to create a directory on that remote server where it's going to save all the files that we have on this project. So in this case, just 2 files. We have the bash setup and the fine-tune.py. And it's going to do that automatically and upload it to that folder once we do that. And it happened really fast. These files are tiny, so it already uploaded to the virtual server, the cloud server. And there's another thing that's happening. PyCharm is looking at all the stuff that we've installed into this virtual environment and making sure it's updating, so it knows what it has in there. All right, so all these red errors are going to go away once it realizes, we've already installed Torch, we've already installed all the stuff we need for this script. All right. So I'll give that a minute. I'm going to pause the video while this Python interpreter updates, and I'll be right back. Okay, everything's updated now. Let me walk you through the high level of what's happening in this script. Really, there's 2 big blocks here so what this script is set up to do, like I said at the beginning, is set up to run different types of setups to run a fine tune. One setup is going to be just using Unsloth. Another one's going to be set up using Accelerate. Another one just running with 1 GPU as if just normal. We're not going to use Accelerate. And so you have different options here that are embedded in this script. So we're going to start with the first option, which is just, I'm going to run this thing on a single GPU, not using any special package or anything like that. I'm not going to use Accelerate even. I'm just going to run it on the normal TRL trainer. And so I'm going to unblock out that first option. And then the second option, you can't run both. Or if you do this both ways, it will do the Unsloth second version. So this is the code to run it with Unsloth. It's a little different, so I'm going to block that out. Not a whole lot different, but a little bit different. Everything else is the same. We have the data setup and the training that occurs at the bottom, and that is actually identical whether you use Unsloth, Accelerate, or just the normal TRL trainer. All right, so a little bit about the data setup. Again, I can go into a lot of detail on this, but I'm basically, like I said, using that CNN Daily Mail data set. There's a specific version that I'm using, 3.0.0. This is mostly for testing right now, so it's not clear to me which one I'm going to use at the moment, but I just grabbed 3.0.0. And then I'm just creating a data set for us to do some testing. All right, I always use pandas because I'm just used to working with pandas. So I convert the Hugging Face data set back into a pandas data frame. And then I just keep the first 10,000 rows for our tests. When I do the real fine tuning, I'm going to probably train it on all of the data, unless I can see a way to kind of clean that data up or get news articles that are maybe longer or something that I want the model to be good at. All right. Then I put it into the chat template that is consistent with Mistral's instruct chat template. You have a start of instruction or start input token, this S, and then you have an instruction where you tell it this is the instruction I'm giving you. And the instruction I'm going to give it is please summarize the following news article. Then I'm going to feed it the news article from the data set for that particular row. And then I close the instruction token. All right. And then what would normally happen is the model would then know, okay, it's my turn to spit out an answer. All right. And I'll keep spitting out an answer until I predict this end of sequence token. But for fine tuning, I'm going to actually give it the answer that I want it to give, which is the highlights part of the data set. So I want it to basically learn that given this instruction, this article and this instruction, I want you to try to produce a summary that's really close to what this CNN data set does for the highlights part. So it's basically going to learn how to give summaries that are similar to that data set. That's the point of fine tuning. All right, so I just apply that function to each row. So I put the data in the format that we need. And I was just checking how long some of these text columns are for the data set for the fine tuning, just because I was trying to figure out how to set the max tokens. I set it at 8,000, that's plenty. None of the inputs in this data set are, I believe, even over 5,000. So I just want to make sure that max sequence length is big enough to fit everything in it. All right. And I convert it back to the pandas data frame, our data set structure. And then I run a couple tests to make sure that everything is working, that we're not getting extra special tokens or something like that, which is fairly common actually for I've found. So I make sure that everything's set up properly and then go on to the training part of the code. All right. I want to make sure this this video is not too long, so you can see all the details in the code below. But let's go ahead and run. I'm going to run it down through that part that we just talked about, where I do the checks here. And so to run that in PyCharm, you can just run certain blocks by highlighting it and clicking or typing Alt-Shift-E. All right, so I'm running it, and it's going to take a little while to run this. Yeah, it's going to take a while to run this because it's never downloaded this. This is a brand new environment, so it's never downloaded the Mistral 7B before, so it's got to download all the checkpoints. It's also going to have to download the data set, so it's going to take a little while. So I'm going to pause this and wait for this to run through, and then be back with you to show you the checks and then what the training setup looks like. Okay, we're all set. It downloaded the model, downloaded the data, and ran these checks. So I just want to show you what this check is. It's really important because it's easy to mess up the chat template and get too many special tokens or not enough. So I like to check. I'm just grabbing one of the rows of the test data set that we're creating, or the training data set that we're creating. There's just one column called text, and it should be in the proper prompt format. So what I do is basically take that row, encode it, and then decode it. All right, and the decode should look exactly right. It should have all the right special tokens in the proper formats. So let's double check that. And so it looks correct here. This is the instruction, starting with the sequence, starting sequence token. Then I give an instruction, please summarize the following news article, and then followed by the news article. And then once it's done with the news article, it's done here. It ends with the end instruction special token, and then the response that the model is supposed to learn is to give this summary nice and concise here, and end the summary with the sequence stop token. All right, so that looks good. Everything is set up perfectly. All right, the next time I run this, it'll be quick, so I won't have to pause it because it's now saved on the virtual machine. I forgot to show you guys, and I suppose I should, that this environment is set up correctly. We have, if you type NVIDIA SMI, you can see I do have two A100s here, 80 gigs each, and that's the machine that I'm working with at the moment. All right, so you can always check that after you get logged into your vast server. All right. Okay, so next step is I wanted to show you guys a little bit with the training setup. All right, so this is all about testing. So I don't really care about saving. I set that at a really high number. Same with logging. I want to test speed, so I don't want to muddy that up with logging and things like that, and saving that could slow things down. I'm just going to test this for one epoch, so running through all 10,000 rows in the data set. How fast does that take? How long does that take? And I'm not doing any eval to slow this thing down. Again, I just want this thing to be nice and pure. Like, how long does it take to train this? In fact, when I do the real fine tune, I won't do eval either. In the training script, I will grab the checkpoints as they're saved and use a different machine to do eval to not slow down the training. All right, that's the way I like to do it. Okay, so what's going to happen here is I'm going to put 10 batches per device. So if it's one GPU, it's going to take 10 of the rows from the data set and use that to fine tune each batch. And will not update the weights until it gets through five of these batches, essentially, is what's happening. So it's going to do 50 rows, essentially, for updating the weights. So really what it makes is it makes the batch size sort of artificially 50. All right, I'm just going to run this through sort of normal setup here, brain float 16. All right, everything looks fine. To save memory, I also use gradient checkpointing. And so I'll do that in the real fine tune as well. So I want to set this up at the real thing so that it's a real test. I also will set it up so that it trains just to learn given the input of the data set, that instruction part, I want it to learn how to give the response, right? So I'm going to be training this on the responses, the completions only. And in order to train on completions only, you have to do these 2 lines of code basically to tell it, just focus on learning the stuff after this special token. All right, that's basically what I'm telling it to do here. The reason I'm doing that is, again, I don't care that it learns the news articles themselves. All right, I don't care if it can predict the next token inside the news article. I want it to use the news article and then use that information to give a good summary, right? And so in that sense, I want it to be able to predict the next token in the summary portion. I don't care about the news article itself. So that's why I'm putting this setting to train on completions only. All right, and then the rest is just telling the trainer all the stuff that you set up, right? So what the data set looks like, max sequence length, what's the data set called, if we're using this training on completions only, which we are, what's the tokenizer, and stuff like that. All right, that's it. All right, so let's go ahead and run this training. And so this will be our first run of the test. This is just going to be like the default test with one GPU, running it through one GPU and see what how long it takes to run through one epoch on one GPU. All right, so let's go and run this. All right, see it's loading the checkpoint shards a lot faster now. And so this is without running Accelerate or anything like that. Again, this is just running with the SFT trainer and TRL, and it's slightly different configs, it seems, than when you run it with Accelerate, even with one GPU. So this will be one test, just the sort of standard trainer. By the way, I didn't probably mention this at the top, but it should be clear that I'm using flash attention too, so there is some speed up involved with that. And so, yeah. Okay, I think it's working. One way to check that it's working is we can do our NVIDIA SMI that I just did a little bit ago with you and just double check that it's training on one GPU. NVIDIA SMI. Oh shoot, it is training on both. It's training on both GPUs. All right, so sorry about that. We're gonna back this up. I don't wanna do this test. Actually, I'm just gonna use the Accelerate because I wanna do one GPU, and I forgot that it will automatically split if I run it. And the reason I know this is running on both GPUs is you can see both GPUs are full power right now, and they both have a bunch of data loaded into the memory. So I'm actually gonna stop this and restart with using the Accelerate setup. All right, when we use Accelerate, I can tell it to run on just one GPU. All right, so the part that I'm gonna show you right now is, all right, this part, how to set up and run this with Accelerate. I'm gonna run it with Accelerate first by just running it on one GPU. And in order to do that, I first need to configure the Accelerate, and then I'll run it inside the terminal. That's how you use Accelerate. So, let's see, I'll just run it within this terminal that I have set up here. But first I need to get into this directory that has all of this stuff on the server. And so I'm gonna change directory. See, I have my virtual environment set up, change directory, and I'm gonna go into the directory that this project is saved on. The way I find that usually, there may be an easier way, but I click on the settings here and then click mappings, and you can see that everything is being saved on the server in this folder called temp PyCharm project 955. And I just copy that, and I'll go back in the terminal and paste that CD into that. All right, paste that. All right, so we're in the project directory. Just to double check, you should see that we have our files in there. We have the bash setup folder, our file, and we have the fine-tune.py file. We also have a folder now called training results because I just started running that training. That was not right, but I can go ahead and delete that just by doing rmr training results. All right, now it's gone. Okay, core.557, I'm not sure what that is. It shouldn't be a problem though. All right, so I'm gonna set up the config here. So what you need to do if you're gonna use accelerate, which we are here, accelerate config. All right, set up accelerate config. And it's gonna ask you a series of questions. The first question is, are we, let me make this a little bigger. Which compute environment are you running? We're going to run this on this machine, right? So just hit enter there. And we're not going to do distributed training. Type of training that we're going to use here, you can do multi-GPU, which we'll do next, but we're going to do no distributed training first. This is just going to be our baseline case with one GPU without using Unsloth. No, I don't want to run it on CPU, so I'm going to say no to that. I'm not going to optimize the script. I'm not going to use deep speed. I will try that later and see how that works. I've never tried that before. And which GPUs are we going to use? Let's just use the first one, which would be index 0. All right. You can see that on our NVIDIA SMI here. This is index 0. We're going to run it on this GPU only. And BF16 is the type of precision we're going to use. That's optimized actually for the A100s. And it's all set. We set up our config. Now you just do accelerate, launch, fine-tune, whatever the script is called. In my case, it's called fine-tune.py. All right, hit that and it should run the training. Yep, it's running. And again, we can double check when this loads the shards. Okay, let's double check. I can't do it here, but I can kind of cheat. Since this is my machine, I can SSH into the server and see the load on the different GPUs with NVTop. And so I'm going to do that. I'm going to open a new terminal here and cheat. You wouldn't be able to do this if you use VAST and you don't own the machine, but I own it. And I have, like I said, 3 servers. I'm not sure which server I actually rented here. It might be a server I call Big Boy. So let's SSH into that and see if that's the one. I'll be able to tell just by the script name when I do NVTop. Okay, it looks like it is not this one. See, there's different projects running, but those are not mine. And I know that because I'm looking at the file names here, and those are not what we had. All right, so it must be a different computer I call Tron. So you've got SSH. I can SSH into Tron really quickly. And NVTop. And let's see, this is it. Yes. You can see our script is running here on this GPU 2 in the global machine setup. And so you can see that it's our script because it's running in this virtual environment called test unsloth v2 GPUs, Python 3, fine-tune.py. All right, another advantage of running, by the way, and of running your stuff on my machines is you don't have to worry about security. You can trust me. I'm the only one that has access to these machines. And so there's your data is safe here. And if you run it on a different VAST server, there's a possibility that, you know, it wouldn't be quite as secure. But our machines are locked down. They're here. I'm the only one that can access them. And I would not jeopardize the security of anybody's project. All right, let's go and let this run. I'm just going to check in with the predicted speed here. So it looks like the prediction on it, oh man, I didn't really plan that very well. It's predicted to take an hour and a half to run this script. Okay, I wish I would have set up this test to be shorter. And in fact, I'm going to pause the video and I'm going to change that so it runs for like maybe 20 minutes. So I'm going to make the data set quite a bit smaller for these runs. All right, so I'm going to modify that, rerun this, and be back with the results. And then we'll do another test where we switch to Unsloth to compare the speed there, and then do multi-GPUs. So pause for a moment, and I'll be back. Okay, quick update. I changed the data set from 10,000 down to 2,000 rows just to speed up these tests. You can see the GPUs, it's got quite a bit of space left, but that's fine. We're using 41 gigs of memory, and that bounces around a little bit depending on how big the batch, you know, how long the news articles are and such in each batch. And so everything's running fine. You can see the training is going on nicely here, full power on this GPU, often actually getting above the 300 watt threshold. Not sure why that is, but that's good. That's one way to check whether your code is efficient if it's using full power on the GPU. All right, and you can see this is training much faster. To run one epoch is projected to take 14. Well, we already run for 1.5 minutes, so it's going to take like 15.5 minutes or so. But I'll get the exact time, and once this is through running, I'll record the. I'm going to zoom this in a little bit so you guys can see better. There you go. You can see that better? Okay, you can see actually we're training 335 million parameters here with this test. I'll run this all the way through, and remember the memory is about 41 gigs, and we'll get the time for this run, and then we'll compare that to Unsloth and then the 2 GPU setup. Okay, quick update on the training here. It looks like it's going to take about 16 minutes or so for the first test. That's with 1 GPU using Accelerate. And just so you see too, the memory usage, it's jumped up as, you know, it gets different sized batches, and as it's doing back propagation, it's saving more stuff in the VRAM. So we're up to 68 gigs or so at its peak here, it looks like. So I'm going to record those in our results and check in with you when this is complete with the final stats. Okay, it's finished. It did take 15 minutes, 58 seconds, and I'll record that for 40 steps. And the RAM usage did get very high to the peak, almost, I think it was 77.2 gigs. All right, so I'll record those, and now on to Unsloth. All right, so I'm going to pause this and be back with you in 1 second. Okay, we're back. Recorded those stats, and now let's run our second test, which is going to be Unsloth implementation of this code. So I'm going to block out this option 1. You can do that quickly in PyCharm just by control and /, and I'll unblock option 2. That's the Unsloth implementation. And then just click run, and it should run on just 1 GPU using the Unsloth setup. So let's try that. Actually, one thing I need to make sure, when I run this code, it's running from the file that's saved on the server. So one thing I need to make sure is that the file on the server just got updated with what changes I just made. So you can right click on the file, do deployment, sync with deployed, and double check that the files are the same. And it looks like it's set up so you got both files here are identical, so that's perfect. All right, just want to make sure that I do that before I run it with the same implementation again. All right, so here's Unsloth, right? It gives you a cute little sloth here picture. It's exactly the same setup, and we'll check how long this is going to take. I want to see it start running here before I pause the video. But yep, we're going to have 40 steps here, same setup as before. And see, so you can see here, Unsloth does claim to be 2 times faster. But again, it's not clear to me what that comparison is. It's probably not comparing to if I have flash attention 2 on like I do. And, you know, we'll see what the speed up is going to be. I don't want to see the first estimate here. So it's looked like it's projecting about 14, almost 15 minutes. It's not much of a speed up, certainly not 2x, but there may be some memory savings as well. So I'll let this run and I'll be back with you with results a little bit later. Okay, checking in, it looks like the Unsloth training is about halfway through, and there are some interesting differences here. A little bit surprised. So the speed is not much better, although it is better. You know, in percentage terms, I guess it is quite a bit better. But the memory is way different. So at this point in the training, in the original Accelerate configuration, the GPU RAM, the video RAM, spiked up to 77 gigs at this point. But remember, it started out at 41 gigs and then flared up. With Unsloth, it's staying at 41 gigs the entire time. So I'm not sure why that would be. Be worth digging into after I complete this video, but it's an interesting benefit, and it's quite a bit of RAM savings with their script. And so perhaps the saving on memory is the big benefit from using Unsloth, at least in my tests so far. But I'll let this complete and then we'll run into the multiple GPU testing. Oh, you can see it just jumped up to 44 gigs now. Still way below the 77 that we had with the previous run. All right, I'll pause. All right, the Unsloth run is just about complete, and it has spiked up to 50.2 gigs, but still significantly lower in terms of VRAM usage. And it looks like it's going to come in at quite a bit faster time too, although not 2x. But I'll wait for this to finish and record, and then we'll switch to 2 GPUs. Okay, it finished at 13 minutes, 33 seconds, you can see right there, and it used less VRAM, but I'll summarize these results in a bit. Time to switch now to the 2 GPU training with Accelerate. All right, I gotta do that in the terminal, so I'll pull my terminal back over. I've gotta change the configuration, so change the Accelerate config. All right, just make sure you guys can see what I'm doing here. All right, again, we're running the training on this machine, but this time we're going to do multi-GPU. How many different machines will you use? I'm just going to use one machine, but you can run on multiple machines. I've never tried that, but I plan to do that in the near future. I'm not going to check. I don't want to slow this thing down. Do you wish to optimize? No. I need to test those things too. I'm not using deep speed, not fully sharded parallel, not Megatron LM. How many are we going to use? We're going to use 2 GPUs. And what GPUs by ID? If you put all, it will just use all. And again, brain float 16. All right, the config is set up. Now let's launch the script. And launching. Oh, shoot. All right, I'm actually glad that that happened. Interrupt that. I forgot to change the script. All right, let's go back and comment out the Unsloth setup and go back to option 1, which was the normal setup for Accelerate. Okay, so I'm going back to training on using the Accelerate setup, not Unsloth. Unsloth free only supports 1 GPU, so that was just going to redo the previous run pretty much, I believe. I'm kind of surprised it even started running. But let's double check that these are updated. And you see it wasn't updated yet. I have differences here. I'm going to push that change just with this synchronized selected. All right, now we should be ready to go. All right, back to my terminal. I was just, again, making sure that the code was updated there. And let's launch the script. And we can, again, because I own this machine and have NVTop set up, I can watch as this is loaded onto 2 GPUs. And yes, that's happening. You can see GPU 2 and 3 are the ones we're running on, and they're both getting loaded with the weights. All right. And it's mapping the data to the 2 GPUs. It did that. Now it's running. Oh, another thing I need to change here. Actually, I'll just leave it. It's going to run fewer steps, right? Because it's got double. Since we have 2 GPUs, essentially what's happening is they're both running at the same time, right? And we're going to have double. We're going to have double the amount of batch size, essentially, that we're running effectively. The batch size doubles, and so there's fewer updates. And it's not really a fair comparison, though, so let's change. Maybe it is a fair comparison. I mean, we're still running one epoch, right? But it's going to have fewer updates. So let's make sure the updates are the same. I'm going to modify this one more time. Let's double. So I just did Control C to stop that. All right, let's make sure that we have a fair comparison with the same number of updates. We're going to have 40 steps. So one way to do that is to, since we're running with 2 GPUs, we can have cut the batch size in half. All right, so let's do 5. Okay, and so that would be equivalent, I believe, right? So we're doing 40 steps running through the data set with the same number of updates, but just with 2 GPUs. All right, again, let's make sure that this is updated. So I just switched the batch size to 5. All right, and again, make sure that that's updated. So it's now 5. I'll refresh that just to make sure. Okay, contents are identical, perfect. All right, now let's run this one more time, hopefully with the right settings this time. All right, it's running, and let's double check. It's loading on both GPUs. Perfect. Some of these printouts here, I'm just making sure that the tokenizer is the same as the one that was used for Unsloth. The padding is on the right side. We have a padding token, which is the unknown token. This 335 million is the number of trainable parameters. This 2649 is the max token size of the input. Some checks that I ran in the script. All right, so you can see we've got our distributed data parallel setup going on, 2 GPUs. We have 40 steps, so everything is the same now. And you can see it's projected to be quite a bit faster. It's going to take projected about 8 minutes. Remember the first run with Accelerate with 1 GPU took over 15 minutes, so it is about half. All right, it is twice as fast about with 2 GPUs. So it appears it's going to be quite a bit faster than Unsloth to go 2 GPUs. So this is the decision I'm going to need to make when I want to do this full fine tune. Just based on what I'm seeing right here, speed matters a lot to me. So I think I'm going to go with 2 or 4 GPUs for this fine tune coming up to make this fine tune news Mistral news expert. News summarizer expert. Okay, I'm gonna let this run and check back in with you when this is finished, and maybe we'll try the deep speed as well, although this video is getting very long. Okay, the 2 GPU training is almost complete. You can see the max VRAM that we're using on one of the GPUs is 58 gigs, the other one's 53. Plenty of headroom there. Interesting, this is the batch size could probably be bigger and handle that just fine with the 2 GPU setup. So 58.2 gigs, and looks like it's going to wrap up at 7 minutes and 53 seconds. All right, let me pause this and make some concluding remarks. I think I'm going to save a deep speed discussion for a different video, but I'll run some tests maybe offline. Okay, back with the results. Like I said, I'll save the deep speed discussion for a different video if there's demand for that. So here are the results, and a little bit surprising that Unsloth wasn't faster, quite a bit. You know, it certainly wasn't 2 times faster. It took 16 minutes about for 1 GPU on Accelerate, although the RAM usage was a little concerning. But with Unsloth, RAM was quite a bit lower at 50.2. 13 minutes, only a couple minutes faster, like 2.5 minutes faster, so certainly not double. But the clear winner in my view is the two. If you have access to two GPUs, it's excellent. The max RAM usage on one of the cards, the one that had the most, was 58.2, and the time was almost double. It was almost double the speed. So I think in my case, I will opt for the multi-GPU training. Although I think the clear winner in terms of cost would be Unsloth free. There's no cost to use Unsloth, and it's going to get you a boost on one GPU, so your costs will be lower for rental, even compared to if I have my case here of using two GPUs. It's not. Yeah, the math will work out, so it'll be actually cheaper for Unsloth free. All right, so that's it for this video. I hope you like it. Let me know in the comments if you want to see the deep speed tests. I'm going to try that out, maybe offline, and see if there are benefits to deep speed. I don't know enough about it at the moment. I need to research different versions of it, and run some testing. But then I'll be off and running and training this Mistral 7B model to be an expert in news summarization, and I will create a new video showing the difference between Mistral out of the box for like news article summarization, and compare that to my fine-tuned version. So you have that coming up. All right, thanks for watching. I'll see you next time.